So what I'd like to share with you is a custom function called JSON dictionary compare, and it allows for the comparison of two JSON objects that are dictionaries. That is, they're storing values under keys. And you can see here the first two parameters of this function are in fact for JSON dictionaries. The remaining parameters are flags that allow you to specify the format of the output. And this last parameter here, depth, basically tells the custom function what sort of level of scrutiny you want it to use when it compares the JSON. So let's go ahead and take a look. I've got here an example where, for starters, JSON A and JSON B are actually identical. So if we run the function, we'll see the output over here. And you can see it's just an empty array, which signifies that there were no changes detected between the two blocks of JSON. Now, if we were to go in here and change a value, say change that from blue to red, and rerun it, what we'll get is an array that contains an object inside of it. And I refer to this object as a delta object. It's an object that basically specifies what changes were detected between one value in A and the corresponding value in B. So you can see here the key is listed to tell you which value we're talking about. That would be the favorite color entry. And then you can see there's a status flag that says that it changed. And then we've got a snapshot of the value A and then the value that it was changed to in value B. Okay, let's change a couple of things. Let's change broccoli to sandwich. And we'll change lucky number. And now if we take a look at the output, it's basically the same concept, but instead of one delta object in this array, we've got three delta objects, each one corresponding to one of the changes that's occurred. Okay, now let's say, for example, that we've got an element in one JSON block that's not in the other. So let's add a city block to JSON A, and let's make a comparison. You can see here we still have our entries for changed, but we've also got an entry here that shows that the city item has been removed from the JSON. Okay, and similarly, if we were to have added a key, let's go ahead and add something like state. This time what we see is everything that we saw before, plus a delta entry that indicates that the state has been added. Okay, so that's basically the sort of things that you can see here. It returns you added, removed, changed items. Now, there are some flags that you can set to organize how this output is returned to you. The first one that I'll show you here is organizing the output by key. If we check that off and run a comparison, you'll see that this time we get a JSON dictionary or a JSON object, and the values are indexed under the keys that they originally appeared in the JSON that we're comparing. So here we can see the city value was removed. We can see the previous value, the new value, similarly for favorite color, food, lucky number, state. So it's basically just a different method of organization of the output. Another possible organization option is to categorize the output by what I refer to as the status, which is whether it was added, changed, or removed. So here you can see we've got a dictionary with added entries, changed entries, and removed entries. You can combine those two output formats, and that looks something like this. They're still categorized by the change type, and then inside of those sub-objects here, you get the list indexed by key of the various items that were in the two dictionaries. Okay, so let's add one more flag here. Let's go back to something simple. And in fact, let's reset this example and just change one thing. We'll change that to red. Okay, so this is what we're used to seeing, just that one delta. There's a flag that you can set that says to include the unchanged objects. So if we set that and rerun this time we get a delta object for everything basically, because we're including delta objects that show items that have not changed between the two JSONs. Okay. So the next thing that we can kind of see down here is that down here where vehicle, which hasn't changed, we've got value A and value B just like we do for all of the other delta objects, but you may notice that the value has been serialized into a string of JSON rather than being represented as a JSON object. Now the reason that is because we haven't specified depth, and when you don't specify depth, it operates at a default value of 1, which looks just like this. 1's basically telling the function only look at the top level entries and do your comparisons there. Okay, now if we increase the depth to 2, what that tells it is to take one look further into the structure as it's making its comparisons and returning its output. And that would look something like this. So you can see here, this time we still have a delta object that indicates that the vehicle hasn't changed, but this time our value A and value B are actually specified as JSON objects as opposed to strings, which are JSON representing those objects. And additionally, if we were to start changing some values around, let's change that to true. How about if we change that to CRV? And we look at the output. This time, if we look just under our vehicle object, which is everything here, you can see that we've got our value A and our value B, but we have this additional attribute called values changed, and it delineates the changes just in the same sort of format that we've been seeing before, where it tells you the key, what's changed, the value A, the value B, and so on and so forth. So it's actually going one level further to tell you the differences that it's finding between these two vehicle objects, rather than simply telling you that they're different. And that's because we set the depth here to a level of 2. Okay, let's go back to something simple again. And let's see what including metadata looks like. If we do that, set that flag for metadata, you get an additional object with the output that tells you how many items were added, changed, removed. It also provides counts of the top level elements in each of JSON A and JSON B, and how many elements were unchanged. So again, let's do some variations here so that we can see this in action. We'll change that to dog. We'll change this to green. And let's remove lucky number. How about that? Okay, so now we still get the same delta information that we would expect. We've got an entry showing that lucky number was removed, entries showing that animal and favorite color have changed, and you can see up here the metadata indicates nothing was added, but 2 things were changed, 1 was removed, and 2 were unchanged. So basically, if you turn on this flag, you get that sort of additional metadata. So that's pretty much all of the features of this function. If you go through the sample file, you'll see towards the end, I've got some examples to show you sort of like where I think it maxes out in terms of being useful with the respect to the size of what you can put in here. So as an example, let's go to overhead illustration number 1. What I've got here is some sample data from Brian Dunning's site, and it's basically contact information. And I've created some JSON, and I put it in both A and B, and it has 100 top-level nodes, that is to say 100 contact entries, and each one is about 36,000 characters. And in this first comparison, we're going to leave them be the same, no changes between the two, and see how long it takes. And it takes about 2/3 of a second, 0.59 seconds there, to detect that there were 0 differences between those two. In the next example I've got here, what do we have? We have the same data, except I've changed 3 of the entries in here. So this is an example to see what it's like when 3 entries have been changed. Additionally, I've set the depth to 2 because I want to see the details of the changes between the children. And let's run that. And that takes about 2/3 of a second, 0.635 seconds, to detect that 3 items have changed. So you can see it's still useful at this level, but this is probably where I would say it maxes out. I wouldn't go with much more data than what we've got here. And I'll mention that it's not just the sort of quantity of the character count, but it basically, the overhead has to do with how many iterations the function is required to make in order to complete the task. And that's determined by the number of top-level nodes, whether or not you've set a depth higher than 2, or higher than 1 rather, how many subnodes in each child there is, and how many differences it finds. So it varies a lot, but what I'm finding is that with this sort of 100 top-level node example, it's still passable performance. Let's see if we've got maybe one last example to run for you. This is the most difficult one here, where I changed every single one of the 100 entries between the 2 blocks of JSON. Let's see how long that takes. Okie doke, took 2¼ seconds to detect the 100 differences between the 2 blocks of JSON and provide the child details with the depth of level 2. So that gives you an idea of sort of how we've kind of reached the end of the envelope here with respect to the performance and how much I would feed into this. So that's it. I'll be posting this custom function up on the community forum as always. And if you're interested, I hope you check it out, and I hope that maybe it's of use to some folks. Thanks very much for taking a look. Bye-bye.